Welcome back, everyone. Show the missing non-bonding electrons and formal charges for the given structures. Let's start with the first structure. Now, what we want to make sure of is the octet rule. We want to make sure that the octet rule is satisfied for each atom except from hydrogen, because hydrogen follows the duet rule. So let's analyze the given structure. We want to make sure that each hydrogen has only one bond and no lone pairs. So we have 1, 2, 3, 4, 5, 6, 7 hydrogens, and each hydrogen has only one bond, no lone pairs. The duet rule is satisfied, right? And that means hydrogen gets no formal charge, apparently, and no lone pairs will be required as well, right? So we only want to focus on carbons and nitrogen. So each carbon, we have 2 carbon atoms, has 4 bonds. What does that mean? Well, this means that each carbon satisfies the octet rule because every carbon has 4 bonds and every bond has 2 electrons. So each carbon contains 8 electrons around it. Therefore, we don't want to add any lone pairs to our carbons. And what about nitrogen? Well, what we can see is that nitrogen has only 3 bonds. So we have 6 electrons around nitrogen, and this means that nitrogen must have a lone pair of electrons to satisfy the octet rule. Similarly, we are first of all going to add missing lone pairs to the second structure. We start with hydrogens. Every hydrogen has 1 bond and no lone pairs, apparently, based on the duet rule. So we want to consider the 2 carbon atoms. Each carbon has 4 bonds, right? So that means we're not going to add any lone pairs. The octet rule is satisfied. So the only atom we want to consider is oxygen, and it only has 1 carbon-oxygen bond, meaning we are missing a total of 6 electrons to satisfy the octet rule. Now that we have satisfied the octet rule and the duet rule, we want to make sure that we assign the formal charges. Now, let's recall that the formal charge is equal to the number of valence electrons minus the number of bonds minus the number of non-bonding electrons. If we consider any hydrogen, we get 1 because hydrogen belongs to the group 1A. Each hydrogen has 1 bond and no non-bonding electrons. So that means nitrogen would have a 0 formal charge everywhere. We're not going to include 0, right? Because it's nothing. We are only going to include non-zero formal charges. Now let's consider the carbon atoms. Carbon has 4 valence electrons. In each case, for the first structure and the second one, each carbon atom has 4 bonds, right? And no non-bonding electrons. So 4 minus 4 gives us 0 as well. So the 2 final atoms we want to consider would be nitrogen for the first structure. Nitrogen has 5 valence electrons. It belongs to the group 5A. How many bonds? Well, we have 3 around it. And 2 non-bonding electrons as assigned per the octet rule. So 5 minus 3 minus 2 gives us 0. So nitrogen gets no formal charge, and that means the first structure has no formal charges. We're done with it. But finally, we want to consider oxygen. For the second structure, first of all, we're going to include 6 valence electrons for oxygen coming from the periodic table. How many bonds do we have? Well, we have 1. The number of non-bonding electrons that we assigned was 6. So 6 minus 1 minus 6 gives us -1. And therefore, that would be the only formal charge that we have. Oxygen would have a -1 formal charge. And we are done with the second structure as well. And those would be our answers. Thank you for watching.